Let's start now. All right. Terry's ready? Ready? Oh, dang, the projector is off. Turn on about this projector. Wait, what am I doing? It's already down. I need to turn this on. This? Okay. One sec, Terry. Turk, sorry. All right, so last week we would have started off with the second part of the course, that is the embedded electronics part. We started off looking at how to make a GET request from our ESP to a servo. The servo that we used was just a test servo that I found online. The servo allowed us to make requests for, I think we had used two different servos. The Star Wars API, is this the light switch? We had used the Star Wars API and also this other test API called RecBin. We're just using them as test servos because we knew that if we made a request to those servos, we'd get back a JSON response that I could use to show you how to use the Arduino JSON library so that we could parse the JSON response and use the data to do something meaningful in our application or on our Arduino, or ESP rather. So what we're going to be moving on today is how to make a post request from our ESP. So in this case, I'm not going to be using a test online servo. I'm going to be using a servo that I have created in Fast API using the same methods and technologies that I've been showing you all along. So that part shouldn't be new. And we're going to test it using Wakwi. And I have my actual ESP that I can test it with as well, just to give you another more hands-on type of demonstration. So we're going to get started the same way that we usually do with PlatformIO. I'm going to open PlatformIO and I'm going to create a new project. Let me get my iPad for my notes. My PlatformIO taking so long. Hope it don't give me trouble. It's initializing. All right, we wait for this to come up. This is strange. All right, maybe I need to close this and reopen it. Is my Wi-Fi okay? Yeah. Sure. I had to reinstall PlatformIO yesterday because it was giving me beer trouble. I'm hoping it doesn't continue to give me beer trouble. It's low, but load 5. I don't like that. Hold on, did it uninstall? No, unable to read. What? All right. Let's uninstall and reinstall. This is madness. It was working fine yesterday. I really hope I don't have to download this one there again now. All right. Hopefully we don't, but we'll see. So I'll create a new project. And this project I will call post request test. And I'm going to select the dev module like I did last week. And leave Arduino as the default framework. So I'm going to click finish and hopefully this don't take forever. Okay, good. That didn't take long at all. All right, so I trust this author and we get our project structure as set up like normal. Let me close this up. And we write our code in the source folder in the main.cpp.
Sir,
yeah.
should I be seeing the screen?
You're not seeing my screen?
No, sir. Like,
Oh. Okay. All right.
it's just one Philip here and it's,
You know?
Yes, sir, I'm good now.
Okay.
Thank you.
Sorry about that. It might have been when I connected to the projector. Oh, yeah. Okay. So yeah, we'll have the normal setup. We'll write our code in the main.cpp inside the source folder. I'm going to get rid of this code. We don't need this code. And we're going to start off, let me see. So we're going to start off with, where's my code? Hold on. One sec. This. Okay, so just like last week, we have our Arduino.h imported, and that's so that we can write Arduino code. By default, PlatformIO is not made specifically for Arduino, but it supports it, so we have to import the library. Next, we're going to include Wi-Fi.h because we're going to be using Wi-Fi to connect to the network, connect to the internet. So I'm going to say include Wi-Fi.h. And one of the things I see people make mistakes with is leaving out this capital F. The F in Wi-Fi should be capital, just to point that out. All right, so next I'm going to include HTTP client, HTTP client.h, and that's built in. And then the third thing, just like how I would have shown last week, is the Arduino JSON library. And we're going to be using the Arduino JSON library to create a JSON object to send off to our server. Yeah? We use the JSON object as our request body. So Arduino JSON, so n.h. And this particular library should remain red underlined at this point because I haven't added the library to our project just yet. But we can save here and I can add that library just to get rid of this red underline. So making sure that this is spelled properly, I should be able to go back to PlatformIO and then go to Open and scroll down on the left-hand side to Libraries. And I'm going to search for JSON and find the one by Benoit Blanchon. Click on it and I can click Add to Project. Oh, the most recent release was 8 days ago. I think that was the same release as the one from last week. So I'm going to add it to my project, and I'm going to add it to this project here called Post Request Test, which is the project that I just created a while ago, and I should be able to click on Add. Okay, good. So it's showing us here in our platform.ini, which is the file inside of our project down here, which keeps track of the information about our project. It added a library here, Arduino JSON version 722. This caret symbol means that it's not exactly 722. It means it's at least that version. So when you're actually installing the libraries, or when you look through the logs to see what library is actually being written to the ESP, I think at this point it will show you version 743. So it's just showing you not exactly which version to use, but at least what version to use. So it's saying if there's a version later than version 722, use that instead. So that's what this up arrow means. Okay, so I can close this, So our red underline is gone, so that means the library has been detected. Okay, let's set up our Wi-Fi credentials now. So I'm going to go into the include folder, because remember, we don't put Wi-Fi credentials directly in our code. We create a new file called config.h, and we will write two variables, const char, and I will use Wi-Fi underscore SSID. I don't remember how I wrote it last week. I think I just wrote SSID last week. SSID is equal to, and we can use Mona Connect, or since I'm going to be simulating using WACWI, I'm going to put WACWI's Wi-Fi, so I'm going to put WACWI-guest. And this is if you want to simulate with Wi-Fi on WACWI, you have to use the WACWI guest SSID, and the password, constant char, the password is going to just be empty double quotes. So no password with WACWI guest. So we can save that. All right, so we're moving over to our main.cpp now. We're moving back to it. Okay, so let's start with the setup. Void setup. And the setup is where we do a couple things. We're going to set up our serial monitor, our serial communication. Begin, and I like to use 115200. And because I like to use 115200, and the default is 9600, I'm going to have to specify in PlatformIO that I'm using 115200. So I'm going to once again go back to my PlatformIO.ini and set the monitor speed flag, set that equal to 115200. And then PlatformIO will reconfigure itself to know that it should use the 115200 baud rate. And then we'll go back to our main.cpp. Okay, so I have serial set up. Now I can attempt to connect to Wi-Fi. So I'll say Wi-Fi dot begin. And then I'll set my SSID and my password. Oh, you know what? These aren't visible because I haven't included the config.h. So I need to say include. And in double quotes this time, not angle brackets, I'm going to say config.h. So now these two should be recognized. Okay, so I begin, and then I can write a message to the serial monitor to say that I'm attempting to connect to the Wi-Fi. I'll say serial.print line. Wait, serial.print line? I guess I can say print since I'm going to be printing the dots. Connecting to Wi-Fi space. And then I'm going to start my while loop. And my while loop is what I'm going to actually use to attempt to connect. Well, no, sorry. Not to attempt to connect. This line here is what we use to attempt to connect. But the while loop is what we use to check to see if the connection has been made. So I'm going to say Wi-Fi, capital F for Wi-Fi, dot status. So I'm going to check the status and check to see if it is not equal to connected. So I'm checking to see if the Wi-Fi is not connected. And if it is not connected, then I'm just going to print a full stop and then wait. So I'm going to delay 500 milliseconds and then serial.print, just print a full stop. Yeah? So we'll just keep printing full stops over and over and over until the connection is made. And once the connection is made, it will break out to the while loop. So by this point, it means that we have a serial connection. So I should be able to serial print line and say connected. Connected to Wi-Fi. And then I can print what the IP address is. So I'll say serial.print, and I'll just say IP, and then print the IP address. Print line, and then I'll say Wi-Fi dot local IP. So this is what's going to give us the IP address after we've connected. And once we get our IP address, then we know for certain that we are on the network, because the network is what gave us our IP address. And this is something that we just do once, and we do it at the beginning of all of our projects whenever we need to connect to the Wi-Fi. All right, so that's it for the setup for the most part. We're going to come back to the setup in a second. So now we need to loop. So void loop. Right? And one thing that I did not show last week that I think is quite important is when you're writing code for your ESP and it's going to be dependent on you being connected to the Wi-Fi, you can't make a request if you don't have Wi-Fi, right? And up here in the void setup, we know that we connected to the Wi-Fi assuming we got an IP address and we printed this message, right? Let me see, do I have a full stop there? I don't think matter. Connected to Wi-Fi. So we know that we're connected to the Wi-Fi at this point in our code. But it's entirely possible that while we are running the loop, we can just lose Wi-Fi, right? So if we have lost Wi-Fi, we would not want to still make an attempt to make the request because we'd be wasting our time. We don't have any Wi-Fi, so we can't make the request anyway. So what we could do to avoid wasting time and wasting resources is check to see if we have Wi-Fi before we make the request. So I'll say if Wi-Fi dot status. So I'm checking the status again here, and I'll say if it is not equal to WL connected, then just return. Yeah. So this will just make it so that if it gets to this point and there is no Wi-Fi, it will just end the loop and start over. Yeah. So that is if we don't have Wi-Fi. But what if we do have Wi-Fi? If we do have Wi-Fi, we should be able to just continue like normal. We should be able to make our request. So here's what I'm going to do. For this post request type thing, we need some kind of information to send off to our server. We need to make a meaningful post request. So for this, what I'm going to do is I'm going to read a value off of my, what's it called? The analog port. I have an ADC port on my ESP that I'm going to be reading a value off of. So I'm going to have a pot or potentiometer connected to that, that pin, and then I'm going to send that pin value off to the server. So let me set up. Do I need to do any setup? When you're setting up a pin, they're input by default, right? So does that mean I don't actually have to do this part? Pin mode 34, and I set that as input. I think pins are input by default. But just in case they aren't, we're going to set up pin 34. I'm going to use pin 34 as my ADC pin. All right. Let me not say pin 34. I'm going to say pot pin. That's where my potentiometer is going to go, and I'll put a pot pin right here. I'm going to say int pot pin is equal to 34. All right. So anytime I want to reference this pin, I'll use pin 34 or the pot pin variable. Okay, so let us first start off by setting up. Should we set up the variable first? No, let's read first. Let's read and make sure that we actually get a value from our ADC pin. So I'm going to say int raw value is equal to analog read, analog read and then read the pot pin, right? And that's going to store the analog value. The ESP32 has a 12-bit ADC, so that means the minimum value is 0 and the maximum value is 4095. I don't want to send the raw value. I want to send like a percentage. So a percentage between 0 and 100% of what, how much voltage is being read. And this is going to be a percentage of 3.3 volts because the ESP uses a VREF of 3.3 volts, I think. Is it 3.3 or the middle of 3.3? I don't remember. You know the VREF? Huh? The VREF for the ESP? It's 3.3? Okay. Okay. Input is 5? What do you mean? Oh, V in is 5. Yeah, right. Okay. So we'll use this. So what I'm going to do is I'm going to quickly convert my raw value into a percent. And this part isn't terribly necessary, it's just the way I want to send out the value. Instead of sending off a value between 0 and 4095 to the server, I want to send a percentage value. So I'm just going to convert that, so I'm going to say float percentage is equal to, I'm going to say raw value divided, times 100. Let me tell, divided by 40, 95. Again, put a 0.0 here to make sure that it's a decimal division I'm doing, as opposed to an integer division. And then multiply that by 100.0 to keep it as a float. Okay. And then with this conversion to percent, I'm still going to have a lot of decimal places, and I don't want all those decimal places. So I'm just going to cut off and make it so that it's 2 decimal places at most. So I'll create another float here. And again, this is not terribly necessary, it's just for my formatting, the way I want it to look. So I'm going to say percentage, I'm going to say 2dp is equal to, I'm going to say round, and I'm going to set percentage times 100 divided by 100.0. So this is just to get the value to 2 decimal places. Okay, so now that we have our value, let's just check to see if we are able to read the value and print it. So I'm going to say serial.print. We're not actually doing the post request just yet. I'm just going to try to make sure that we have the value to print it. So I'm going to say print, let's print both the raw and the percentage. So raw, and then the value itself is going to be print line, and we're going to print the percentage to raw value. Raw underscore value, that'll be that. And then we're also going to print the percentage value. Oh wait, that's fine. Print percentage, and then serial.print line percentage dp, 2dp, yeah? Okay. So we can start off by just testing this. Let me fix this. Let me just test this out. And I'll start off by using Walkwi. So let's get our Walkwi set up. Let me go back to a previous project so that I can copy over the Walkwi related values. PlatformIO. So I need the Walkwi TOML and the diagram.json. I'll post this Walkwi TOML in the group chat. So you can use this. It is called walkwi.toml, and I'll post the JSON as well. This JSON diagram that I have already has a path on it, so I'll just copy and paste this so that you can use it. Edit this again. Open with text editor. Copy this, post that there. So the first one is walkwi.toml, and the second one is diagram.json. So make sure those are in the root of your project. And with that, I should be able to build this. So let's just build. Ignore this. Hopefully that's not important. Let me see, does it tell me what version? Yep, Arduino JSON version 743. It's building. Okay, so we have it fully built, and now I should be able to run it in the diagram.json. So click on diagram.json. Why is this so zoomed out? Come again? It's in the root of the project. So it's not in any folder. Yeah. Call it walkwi.toml, T-O-M-L, and I pasted the content in the group chat. And you also need the diagram.json. So let me run this. So two things we need to look out for. Oh, whoops. All right, so it's moving really fast. I should have put a delay. Hold on. Let me go back and put a delay. So it's, okay, so delay, let's delay 2 seconds. So the first thing we want to look out for is to make sure that we're actually able to connect to the Wi-Fi. And once we are, we want to look out and see if we can actually read the values that we're reading from, or display the values that we're reading from the pot. So I'm going to run this again, and it looked like it connected really fast. So connecting to Wi-Fi, it connected, and I will have the raw values. So let me interact with this pot. So we're getting our raw values, right? Right now it's at 50-something%. Let's go up some more. 60, 88%, and bring it to 100, and it's at 100%. Yeah? So the simulation itself works. That's good. We're able to get the values from the pot. But that's not what we're here for. Once we get these values, we want to send them off to a server. So let's do that now. Let's start off by creating our JSON document. And just like what we did last week, similarly, if you want assistance with this part, you can always use the Arduino JSON assistant. So let me see. Let's take a look at the Arduino JSON assistant. So for this, what I said last week. Last week I said we wanted to convert a JSON string to an object, which meant we needed to, so string to object means deserialize. But now we are converting from an object to a string. So we're going to create the object first in our sketch, in our Arduino sketch, and then we're going to convert it into a string so that it can be sent off as a JSON string in our request body. So we're going to serialize in that case. And I have selected my ESP32 dev module, and I'm specifying that I want the output to be of type string. All right, so we're serializing in this case because we're converting from an object to a string. I'm going to click on JSON, and now it's going to ask me the string that I want to send, what does it look like? You remember from last week that we're using the Swappy API. But in this case, what I'm going to do is I'm just going to have a singular attribute in my JSON, and that's just going to be the value that I record from the ADC pin. So I'm just going to say value, I'm going to set that equal to 20.3%. The reason why I'm specifying an example value is because I want the assistant to recognize that the value I'm sending is going to be a float, so that it can appropriately set the values needed for me to send off this data in a JSON. All right, so this is the only thing I'm going to be sending, and I can click on next. So very simple. It's telling me what I need to do is create a JSON doc and then set the value. So in this case, I'm using the key, in this case is value, and the value here is in my example 20.36, but we're not going to be using this hard-coded 20.36. We're going to get this from our ADC pin. And then we have a string output, which is what we're going to use to store the document when it's created and then send it off. So this is our empty string. This function here is going to take the document that was created here, and it's going to try to format it and parse it and convert it into a string and store it inside output. So that's what the serialized JSON function is doing. It's serializing the document into a string. And then we can use output, in this case here, as our JSON body. This shrink to fit, I think this just helps with saving memory. Normally what it will do is if you have a case where your JSON looks like this, so if your JSON looks like this and it's on different lines, and you have this here, and you have that, and then this, and then that, and all that stuff, like it's in different lines, I think the shrink to fit function will just put everything on one line to make it so that it saves on memory, so you don't end up sending unnecessary data in your JSON body. And the unnecessary data in this case would just be like the new line and the spaces. So it just minimizes the amount of characters that you have in your JSON body. And we'll be using that. So I'll just copy this and I'll paste this here. Okay, and we're not going to be using this 20.36. Instead, we're going to be using our percentage 2dp value, percentage 2dp. Yeah, so what this will look like is something like this: value colon and whatever the value of percentage 2dp is. Yeah, so that's what this is going to look like. So then we have our string output. I'm going to convert this, or not convert it, I'm just going to change the variable name from output to JSON body. Take this here, it's going to shrink the document, and then it's going to convert that document into a string and store it inside the variable called JSON body. And once that's done, I should then be able to start setting up the HTTP client so that I can make a request to the server. So we'll have the JSON set up already. Next thing, HTTP client. We're going to set up our HTTP client so we can make a request. HTTP client, HTTP, and we're going to begin a connection to our server. So HTTP.begin. Oh, I don't have a server yet. Let's specify the server URL up here. So string. Wait, can I use a string? Or do I need a constant char? The results from the ADC, you mean? Oh, come again? Oh, so make sure you build based on what you have already. So let me save this. So build, and once you have built successfully, might not get built successfully. I need to put something here. Hold on. Build again. And as long as you have your walkway.toml and the diagram.json, make sure the values are set up correctly in this. Wait, why is there an error? Oh, there's no error. Okay, after you build, you click on the diagram.json, and you should just be able to click play. And it should take your files and write it, and you'll see the output in the terminal. Did that work? Tara, did you get it to work? Or I'm not sure if you're following along, like if you're coding along with me.
Yeah, I'm behind, but
Okay, no problem.
yeah.
If you want me to pause so you can catch up, I can pause.
It's okay, sir. It's okay.
All right, cool.
I just have to watch it over and continue.
All
But
right.
I'm slowly progressing.
Okay, cool. Is it?
So I'm gonna copy the same thing,
Mm-hmm.
and then this.
Click there.
Yeah,
It says firmware not found. You build, right?
yeah,
Hold on, let me see. So click on PIO, and then go to build. ESP32, yeah. The files are there. Wait. Oh. You put the walkway toml inside the test folder. Just click and drag it out here, so. Yeah. And so move. There's a diagram.json, same thing. So you put it in the test folder. Alright. Go back to the diagram now.
So what's separated from the test file? Like this or that?
Because look at the indentation. So click on test again. Whatever is inside the test folder is indented here. Alright, so now it's going to connect to Wi-Fi. Alright, yeah. So you'd have a delay, but that's fine. So here's working. Cool? Okay. Alright. So we'll go back to our main.cpp. I'm going to set up a server URL so that I can actually connect to my server. You know, let me spin up the server. Meantime, I have a server application in this that I can just copy this here. And I can give you access to this server as well. I think I need to delete this and this. And recreate it. Let me give you access to the code that I'm using so you can test it yourself. I'll give you a code here. Pretty long, but that's just because there's a lot of HTML in it. This server acts as a front end and a back end. Okay, so you deploy it just like normal. There is a requirements.txt. The requirements.txt is just fast API and unicorn. So you install just like normal. So let me do that. Let me create a new terminal. Wait, hold on, let me kill this. I'm confusing myself. Okay, so I'm going to change directory and navigate into the API folder. So I'm going to say cd space API. So wait, what? That didn't work? I have the API folder. Oh, that's strange. Why didn't that work? Oh, API folder isn't in this folder? Why on earth not? Why can't I move it to the folder? Are you sure? Yes, I am sure. Okay, so now it's in there. No, that don't make sense. Hold on. I want to put this folder in here. Yes. Wait, now move. All right, one sec. Let me close this and reopen. Yeah, make a app.py inside the API folder. This thing I move rather strange. Yeah, there's a front end in it. It's in the code. It's in the API app.py, the code here. Yeah. Oh yeah, man. Let's open up a recent project, which is this one. So we're gonna open. Hold the phone. Why is that? New window. Close this. Save. No, don't save. We don't care about that. Don't save. Here, PlatformIO. Open this one. Okay, so I'm open directly to the project now, and my API folder is gone, so let me reveal this. Go here, where the API folder disappeared to. Post request test. All right, it never store, which is very strange. Anyway, let's copy it again. So copy API here, add folder to workspace. Okay, so now I have an API folder. So now I'm going to cd into API. What? Oh, it asked me if I want to add it to workspace. That's not what I wanted to do. I want to remove from workspace. What I actually want to do is add a new folder. I'm going to add a new folder, easier. New folder, API, and then just copy the content of this into that folder. Okay. Now I can cd into API. Good. And I should be able to activate, is it? Oh, I created an API folder inside my project folder. And then I added the app.py and the requirements.txt to it. You don't really have to add the requirements.txt because it's just two files. or two entries. We can do that manually. So you added the app.py folder, and then you created the app, yeah. So now I navigated my terminal into that folder by saying cd space API, so that my terminal knows that I want to perform an action inside that folder, yeah. So now that I'm inside the API folder, I'm going to do the virtual environment, Python, all right, -m venv. And I'm going to activate my virtual environment. All right, and now I can pip install. So I'll pip install, and I'll just use the requirements. -r requirements.txt. So it's going to install Uvicorn and Fast API for me. And this Fast API code is relatively simple. I have a simple class or a model that just takes a sensor reading. It has a value and a float like I described in the Arduino JSON. So a value, and that value is a float. And then I have a local storage. I'm just using a dictionary to store the most recent value in my code. And the default value when nothing is sent is that it sets a value of 0. And there's a last updated. And this is going to be replaced by the time when I get it. Function here has a post request and a get request. The get request, all it does is just returns the latest reading, which is this up here. And the post request gets the value from the reading and then stores it as the global variable's last reading value, and then it sets the last updated to whatever the current time is. So it just gets the value from the sensor reading and stores it in the dictionary. And then it returns the last reading. And then this get request down here just serves the front end. So you can just ignore what this does. All it does is send some HTML. And we're going to see what that HTML looks like in just a second. All right, let's spin up this server now. So uvicorn app :app. Oh, and by the way, so in addition to the -- reload, there's another thing that we need to do. Is we need to open up this application to be visible to every device on the network. So typically we'd have just stopped right here and said uvicorn app :app reload. And then that would have made the application or the server accessible to any other application on the computer. But we want to make it accessible outside of the computer. So for example, if you wanted to open up the web page on your phone, as long as the phone is on the same Wi-Fi as the laptop, or more importantly in this case, we want our ESP to be able to access this website. Or not this website, but this API. Because the ESP is a separate individual entity that is not related to this laptop. Because the API is running on this laptop, the ESP is a separate entity. We need to make sure that the API is accessible to any external entities. So we're going to open up the hosting. We're going to set --host. We're going to set that to 0.0.0.0. And those 4 zeros just mean any IP address that this laptop or this computer is associated with, make the API available on that IP address as well. So the private IPs, the public IPs, every interface that this thing has access to, make it available on that. So now I can run it. And my API has started up. Okay. Let's just do a quick test to make sure that the server is running. I'm just going to load up localhost 8000. And this is what the front end looks like. At the moment, the values are blank. This reading value is blank, and there's no last updated because it's none. So when I actually start to use the ESP now, it should populate these values. So let's do that. Okay. So I have my server. Let me go back to main.cpp. I have my server address now, and my server address is going to be server URL. Yeah, it's going to be equal to, and let me ask you the question. What would the API URL be in this case? Given the information I just told you. Okay, so it's a local host. And I want you to remember that this code that we're running, the Arduino code, is not going to be running on this computer. It's going to be on the ESP, right? And he's saying 000. That also cannot be it, because 000 is just a shortcut name that means every IP address. It's not a specific IP address. So I need to tell the ESP which IP address to make the request to. And the server is going to be running on this computer. So I need to put the computer's IP address. Not localhost, not 127.0.0.1, because those are what the computer used to refer to itself. So I need to use my laptop's network IP address. So I'm going to find out what that IP address is by using CMD, and I'm going to type ipconfig. Let me zoom in so you can see it. ipconfig, press enter. Enter. Why does not work? Enter, okay. And I'm going to look for my IP address that looks like 192. Is it going to be 192 or is it 172? Is it this? No, I'm looking for my Wi-Fi. Where's Wi-Fi? Oh, this is my Wi-Fi. Interesting. So 10.191. Blah, 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 blah. Okay, so I'm going to set this. Make sure to put the http:// and we'll put the port, which is 8000, because that's the port that our API is running on. And according to my API code, let's confirm, the endpoint is /API/sensor. So I'm going to copy this and put that here. So that's our server URL. Hold on. Okay, so I have my server URL now. So I should be able to come down here and continue with the establishment of the connection to the server using the server URL. Okay, good. Now, one other thing that we need to add. I would have told you about HTTP requests and how they look when we're making them, the manual way of making them. So HTTP requests, using this. Let's look at the post request. So an example of an HTTP request looks like this. It has a bag of different information that tells the server what it's supposed to do when it gets it. And this type of data is not JSON data. And we know it's not JSON data because the content type tells us what type of data it is. So it describes this type of content. In our case, we're not going to be using URL encoded. We're going to be using JSON. So I'm going to say application JSON and then put a JSON here. So we need to specify that header when we're making the request. So we need to add a header to our request to tell it that we're using a JSON. So I'm going to say HTTP add header. And I'm going to add two things here. First thing, I'm going to specify what the header name is, and it's going to be content type, and I believe it is case sensitive. Then I'm going to specify the value of that header, and it is application/JSON. Yeah? Need to make sure that this is here. Otherwise, when the server gets the request, it will not know that it's supposed to look in the JSON body. Or yeah, it won't know that it's supposed to look in the body of the request to find the JSON. Yeah? So with that, we now should be able to actually make the post request. So I'm going to say http.post and then provide my JSON body. JSON body, just like that. So once we make the post, we'll only know if it worked if we get back a 200 response status or status code. So I'm going to capture the status code from this request. I'm going to say int status_code, set that equal to that. So at this point, if the request is successful, actually let me check something. Okay, the default request, status request of this is 200 because it wasn't changed to 201, but that's fine. So we're expecting back a 200 unsuccessful response. So with that, I should be able to now write an if statement to check to see what the status code is. But let's first check to make sure that the status code isn't an invalid one or one that signifies error. So I'm going to say if status code underscore code is less than 1. Is it less than 1? It's greater than 0, less than 1. Yeah, I think if it's less than 1 then it's an error, or is it less than 0? One of them, I don't remember. So if it's less than 1, then it means that we got an error and that we can just print it. Serial.print, we can say error, and then I'm going to say serial.print line, and then get that error. Oh, really? I can say HTTP error to string status code. I never saw this. What did I use last week? How did I get the error last week? I think I used, I don't remember. Can't look back at it. But for now, I'm going with what my notes say. So I'm going to use error to string and then pass in the status code. So that's going to give us our error based on whatever the status code is. Okay, and then I can return. And you know what? I also need to end the HTTP connection. So up here, I begin the HTTP connection. If I'm going to end the application, I need to make sure I clean up my connection and say http.end here. Okay, but that is only if it doesn't work. Let's move on to if it does work. Okay, two things we'd want to do. If the request does go through, it does not mean that we got a 200. It could mean that we got a 400 or a 404 or something else. That signifies that we did in fact make a request to the server and we got back a response, but it don't mean that we got the response that we wanted. So I want to check and make sure that the response I got back has a status code of 200. If it's not 200, don't do nothing. Only do something if it's a 200. So if status code is equal to 200, then we can get our response. I'm going to say string response body response underscore body is equal to http.getString. So this gets the response body from the response. So now I have this response body, and since I have the response body, I guess I don't really need to do anything with it, because in this case, I'm not going to be using anything from the response body. So I can just print it, just to make sure that I got back a proper response, and we can see what it is. Yeah. So I can print the 200 as well as printing back the response that the server gives me. So in this case, the server is just going to give me back the last reading, which is a JSON that looks like this. And I don't need to deserialize it and use any of the values in there, because it's just a response from the server. So I can just print it and print the status code. So let me say status code and then serial dot print line and it's a status code. And then I can print the JSON. Let's copy this. Response body. I don't think I need this line. Okay, let me see. Is that it? I think that should be it. And then we delay for 2 seconds. All right, let's try this. So I'm going to build. Okay, we built, and now I can go to my diagram and write what I built to my diagram by pressing play. Oh, you know what? No, this will work. Yeah, this should work. Connect it to the Wi-Fi. And let's check the front end to see if anything is happening. Okay, so it says 0. It doesn't say dash dash anymore. Let me put this on the side. Put this here. And I'm going to make changes to my pot. So put it up there. Changes to 48. Oops, let me let it go. 9.3. And it's a bit slow, but it's going to be slow because I have a 2-second delay in my code. Put this up here. It updates to 55%. Put it down here. And it updates to that. 100%. Oops. Max it out. Yeah, just let go. Okay. Yeah. Yeah. So one thing to note, I know that, yeah, it looks like I have some code running on my computer that is influencing what the website looks like. But they're meant to be separate. This website should be able to run on anything, right? Since I'm on the network now, I should be able to pull this up on my phone. The IP address of my laptop is 10.191.176.60:8000. Yeah, so I can see it here. And when I change it, when I change the values on the pot, is this, wait, am I using this one? Let me, oh, simulator. Change it here, it should change. Yeah? It changed, right? Yeah, good, it changed. Yeah? Change it here, it changed there. Yeah? So that works. And just to give you an even more in-depth demo, I did also carry my ESP. Mash up my bag. With a huge breadboard. So I should be able to write the code to my actual ESP and use an actual potentiometer and show that it can be separate from the computer. So let me do that real quick. Where's my USB cable? Did I carry my USB? I did. Okay, for this to work, I'm going to need to set up my actual Wi-Fi. So let me stop recording for a second. Tariq will soon come back. Stop sharing. Let me pause this. And start back the screen share. All right. And yeah, I think the IP address will stay the same. Anything else I need to change? No, I don't think so. So let me write this to my ESP now. So I'm going to have to rebuild because I changed my Wi-Fi credentials. Plug in this part. And then upload. Excuse me. Okay, so open my serial monitor to make sure that it's actually getting stuff. Connecting to Wi-Fi, it should connect. Please connect. It is taking a while. This happened last night as well. I had to upload a few times. For some reason. Where's my phone? That looks correct. Let me try uploading again. Wait, is this 2.4 gigahertz? Yes, it is. So it should work. It failed? What do you mean it failed? Okay. So it uploaded. Serial monitor. Please connect. This thing don't want to connect. But why? Let me reset it. Should connect to the Wi-Fi. I guess even if it doesn't connect, hopefully this issue is just happening to me. If you were to get this working on Mono Connect, it should work, I believe. But I'm trying to connect to my hotspot at the moment. And maybe the ESP don't like my hotspot for whatever reason. Am I using the right password? Yep. This was happening last night when I was testing this out as well. It didn't want to connect on first try for some reason. Let me try resetting. I'm coming again. Oops. I killed the server by accident. Monitor now come up. What was that? Wait. Double check. And make sure. Let me double check and make sure that these are set properly. Continue this. Start this back. And share my screen. All right, yeah. So I don't know why, but it took a while. But I was able to connect after a bag of different dots, and I got the IP address, and now it's sending zeros. Should it be sending zeros? Is it actually at 0? If I turn this, yeah, it works. Yeah, so I'm turning it, turning the physical knob, and it works. And do I really want to test this again? Let me see. Hold on, just to make sure. Plug this into your computer.
Yeah, you might have to do it.
So I just mean, wait, so you don't know what to, no, when I said just plug it in, just so you can get power. Just to show that my computer has nothing to do with it. Hopefully we'll connect back to the Wi-Fi. And you can turn the knob. Press down on the pot when you turn in the knob.
What?
As in, press down on the pot so that it doesn't come out to the breadboard. It's not really breadboard friendly. So just turn it and see if it changes. If it doesn't change, it has not connected. Oh, it changed. Cool. Yeah, there's a 2-second delay in the code.
Yeah, but the color change that's in the HTML.
Yeah. Yeah.
Just swipe
Yeah, man, sure. That's fine. That is fine. So you have access to the code. You can just take it. Yeah, so this is IoT. I have application running on my computer. ESP over there, so they're not connected to each other. You can do a change on that and it reflects on this.
What Wi-Fi?
What's that?
Your
I didn't hear what you said.
what Wi-Fi?
I'm using my hotspot. Yeah.
The color thing I asked about, what is about it?
Turn to 100.
And she, no, it's she,
Yeah, change, yeah.
So you said like that?
Me, AI wrote this. I never wrote this.
That's a very crazy.
I never made this website. Yeah.
So with the Omega here, this have nothing to do with anything? Or just
Oh no, that's just on the breadboard. No, no to do with it. It's just the ESP and the pot. And you would, well, the last updated is showing as well. This is being controlled by the servo. It's getting the raw. This is, I think the raw value is coming from the servo because I'm not sending the raw value. I'm only sending the percentage. Come again? Yeah, but that's not sending the ADC value. So I think the servo is just taking this and just converting it back to raw. So I don't know. I don't know why AI feel like it must do that. Because I could have sent the raw value, but I didn't. And it would have been faster if we took out the 2-second delay after re-upload. It wouldn't be immediate still, you know, because it takes some amount of time for the request to be sent and get back a response. So it would be faster, but it wouldn't be immediate. I think one way we could possibly get it immediate is if we weren't using an HTTP server. We'd have to use a WebSocket server. But that is a topic for another day. So let me see, can I get rid of this 2-second delay and make it as fast as possible? Then re-upload. Tarek, I know that you're not seeing the physical hardware, but it's effectively the same as what I was doing in the simulation. Did that break? It broke. Why did it break? And again. Oh, you know what I forgot to do? I didn't end. I should have done an HTTP end right here. So. Oh, what you said 20? Why did I say 20? That's weird. This said status code equal 20 for some reason. I don't know how that happened. Maybe I pressed backspace by accident. But I need to http.end as well. And then recompile again. Because you need to make sure after you have established a connection, when you finish making a request, you end the connection. Yeah. So you can start a new one. So writing this again. And let's make sure that we actually get Wi-Fi. Why is my laptop about to take off? What was that?
No, it makes much
That
sense.
was, yeah, I don't know. I really hope that something just got in the vent because that sounded like sparks. But I don't smell anything.
Yeah, that's a big thing.
Gee, we need to pull this machine later. All right, let me see now. Yeah. All right, so it's a little faster. Not much, but it's something. So yeah. Any other questions about this? Yeah, I guess it's noisy. I don't know. Fran always says that the ADC on the ESP is not very good. So I assume that's why, but I don't actually know if that's true.
I probably look at that cup.
Hmm?
It worked better if you put that cup or something.
Really? Oh, that's strange. So yeah, what we'd have done, if it's a case where you want to do a put request instead, then you just change this here to put instead of post. The code for the Arduino stuff is effectively the same. And if for some reason you wanted to do a delete request from the ESP, I'm not sure why you'd want to do that, but you just change that to delete. Is that right? Is there a delete here? I guess, no? Okay, there is no delete. Maybe it doesn't allow you to delete. But again, I can't imagine why you'd want to make a delete request from an ESP. But there should be a put for sure. Is there a patch? Yep, there's patch. So you can get, put, post, and patch. But you can't delete. What else is there? There's get, post, patch, put. That's probably it. Yeah, that looks like it. So those are the only type of requests that you can make. Change back to post. Yeah? All right. So question, if I were to give you a lab that was based on this. Well, actually, the lab that's coming up this weekend is going to be a get request lab. So you won't need any components for that. What I'm thinking about for the lab is I'll give you a website that has a light switch on it. When you flip the light switch, it should make a LED on your ESP light up. Yeah? You guys have LEDs, right? So you can just connect a LED. Even if you don't have a LED, you can simulate it. So I'll provide the API and the front end. You click a light switch on the website and it's supposed to make the ESP react. So you're going to be making GET requests to get what the status of the light switch is so that you can make your circuit react to it in real time or close to real time.
Sir, I should be there tomorrow. Is it possible you have any more ESP32?
Yeah, I do. I have some more.
Okay.
Yeah.
And how much for it again? 1,000?
I think it's 1,200. 1,200?
12.
All right, I'm going to put a link in the chat that you can use to remind me
sir.
to bring it to class. So I'm going to put it in the chat. Storage that.
So we can just buy this then.
I mean, this one used. You don't want to use one, you want that brand.
That's another one buy guys are cheaper.
Man, that's my special one. You can get the case if you want. So that's this, and here's the book.
That change?
No. Oh, what? 1,400 or 14 something? You can go to the store and get change. 1420. Get some coins. Tariq, any questions from you? Or are you good?
Where I'm right now, I am trying to catch up a bit because my thing not working, but I should be there tomorrow to go through it with you, sir.
You want to share a screen and I can assist you? No?
Not right now, not right now, sir.
Fine. No worries. But yeah, the
Well, I
video
should
will
be
be
there
there, and I'll post this code on VLE. I'll post in the group as well.
Okay.
This can use the ESP if thingy.
What that?
Same thing when you look on that. Most of them are sign up, you know. It itself use the ESP if dev mod.
Expressive.
Yeah.
Oh,
This one I can use it.
yeah, that's the same as this, you know. The same thing.
Oh.
Yeah, man.
Actually, I have one right the Express if thing.
Oh, is Espressive made the ESP? So yeah.
Overall?
Yeah, they made it. That's why it's named ESP, because Espressive. Yeah. That's fair. That's something you're supposed to know though. Yeah. What could I do in tomorrow's class? I guess I'll think about it. Oh, and well, Reynolds gone. But the recording will be there. I'm going to do the mid-semester next week, Friday. So the mid-semester will be, what will it be based on?
Friday face to face?
No, I'm going to do it on VLE. So I'm going to
Okay.
post the quiz to VLE and you can just do it on your own time. I'm going to post it next week, Friday, and it will act as next week's lab. Or it will just be in lab time. Should I still post a lab? I should still post a lab. How many labs do we need? How many labs have you done so far? 3? So it's 3 fast API labs you've done, right? So this week we're going to make the 4th lab, which is a Arduino lab, which is get requests. I'm going to do a post request lab as well. I'm gonna try to think of something for the last one. Oh yeah, I was saying that I'm going to do the mid-semester next week Friday. Next week Friday. Virgin. Oh, so but I don't have change. I'll bring back your change. All right. All right. I think I can stop the recording, but I'll leave the call going if anything.